done well or have not done well in your last quiz, I think it is time to recoup and get ready for the next quiz and in our 4 weeks, 5 weeks times and exams. So now, okay, just a couple of announcements. The first announcement is from the university. Okay, it's just a reminder that we all have to fresh up that you have to do an e-training module, which is mandatory. Okay, university says it's mandatory. So if you don't do, most likely they'll buy you from exam. So please do. All right. Okay, you have to go to the website and do an e-module by 10th of December. Okay, by 10th of December you have to go there and start. Make sure that you understand what is data protections. Alright, and for those of you, the second announcement is for those of you who have missed the quiz last week. Alright, if you missed the quiz for valid reasons, like for instance you have an MC or you have some excuse letter or whatever, okay, so bring your IC or mention cards and your MC or other supporting documents. Go to E40604, okay, this Friday, alright, from 2:15 to 3:15, there will be a retest. Alright, 2:15 to 3:15. And for those who want to redo to better the score, unfortunately the answer is no. Alright, you can't do it and then try to get a better score. Okay, thank you very much. Alright, this is actually some very simple explanation for question 4 of the last quiz. And because some of you asked, wow, the question is so difficult and what is how to solve this? Actually, it's very simple because part 1 of the quiz, you got 2 current in orthogonal directions. So basically, all you have to do, since there are 2 wires, you just use Ampere's law twice, okay, because it is, not to worry, I will go through the quiz 1 and also the quiz 2 solutions just before the exams, okay, we'll run through the 2 quizzes just before the exam. Okay, you apply Ampere's law twice, for that same point, apply Ampere's law twice, due to each of the individual current elements. Okay, you find that at this point here, the 2 magnetic field actually cancels with each other. The magnetic field cancel each other also here. The 2 magnetic field add up at these 2 points, okay, but at different direction. So that is quite straightforward for 16 marks. And this one for 4 marks is also very straightforward. That you have a current coming out in that directions, and you are asked to find the EMF induced on this loop. But you look at the current that coming out, the magnetic field or magnetic flux is actually running parallel to the XY plane. And if it's parallel to the XY plane, there is no flux linking the loop. And there's no flux linking the loops, there's no induced EMF no matter how current change. Okay, so another 4 marks, that's 20 out of 25 already. And the last part of the question 4 is actually similar to the tutorial questions. The only twist, okay, is that the current now is not a constant, okay? Otherwise, the flux linking is constant, your EMS induced will be 0. But now since the current is not constant, so the flux is not constant, and you differentiate flux by the time, there is an induced EMF. That's all. Alright, let's get back to our class. Let's do a very quick recap on what we have. Okay, do a very quick recap on what we have. The first thing that we have done is that, okay, we say that, alright, these are the Maxwell equations, the Ampere's law, Faraday's law, Gauss' law, in electrostatic and magnetostatic. Okay, now we are moving towards something that moves. The charge does not stay still, the charge moving becomes current, okay, and there will be wave and there will be propagation. Something changes with respect to time. Okay, something changes with respect to time, we need to add another term here, what's what I call the displacement current. and displacement current density. And displacement current density, J is equal to del D del T. Now this is necessitated, okay, from a simple example. Okay, we use capacitor as a simple example. We say that we prove that, okay, there is a need for this so-called displacement current there. Okay, and then we say that, okay, now if that's the case, all right, if we use that our new Ampere's law, and with current equal to 0, charge equal to 0. Why we say current equal to 0, charge equal to 0? Because if we talk about wave propagation in free space, there should not be any current or any charges in free space. Okay, so with that, we manipulate the Faraday's law into something like this. Del squared E plus K squared E equal to 0. This is what we call our wave equations or Helmholtz equations. Okay, wave equations and Helmholtz equations. And we say that, alright, for a simple example, okay, for a simple example, let's say E, okay, is equal to EX UX EJ omega T EX UX. Okay, we say that if we substitute the EX into the Helmholtz equations, we can find that the solutions of this EX should have the form of something like this. Alright, so it becomes E naught E minus J KZ EJ omega T UX. Alright, so now a simple solution for the wave equation is that I have an electric field polarized in the x directions and propagate in a z directions. Okay, K is the so-called propagation constant, which is equal to omega square root of mu epsilon. Remember, when I write mu, I mean equal to mu naught mu r. And when I write epsilon, it is automatically equal to epsilon naught epsilon r. Alright? Because it should have two components. One component is the mu naught, one component is mu r. And for epsilon, one component is epsilon naught, one component is epsilon r. And K is also equal to 2 pi over lambda, where lambda is the wavelength in the media. Alright. Now, when mu is equal to mu naught only, and epsilon naught equal to epsilon naught only, then we have K naught is equal to omega mu naught epsilon naught, which is equal to 2 pi lambda naught. Okay, that is a free space wavelength for the same frequency of propagations. Alright, for the same frequency, in free space, it is this wavelength, and in the medium with mu r and epsilon r, it is this wavelength. Similarly, the velocity c is equal to omega k naught will be equal to 1 over square root of mu naught epsilon naught. Now, all these relationships, okay, can be obtained by substituting into the so-called these wave equations. All right, and v, which is equal to omega over k, okay, which is the velocity of the wave in an arbitrary medium, which is equal to 1 over square root of mu epsilon. Again, mu epsilon, mu is mu naught mu r, epsilon is epsilon naught epsilon r. Alright, so this is a summary of what you have so far. Now, then you say that, oh, I think we stop there. Okay, I think we stop here. Okay, the relationships, of course, the relationship between K and K naught, lambda and lambda naught, C and B should be very clear from here, right? It should be very clear from here. What is the relationship between K and K naught? What is the relationship between lambda and lambda naught? What is the relationship between B and C? But never mind, let me write it for you. Okay, B is equal to 1 over square root of mu r epsilon r. Sorry, C. Okay, mu r epsilon r. Although a lot of time we always set mu r equal to 1. Alright, because in a lot of medium mu r equal to 1. And lambda equal to lambda naught over square root of mu r epsilon r. And what is K? K equal to K naught. What? I'll leave it to you. Alright, maybe I'll just set a class test on it. Okay. Now, then the next things we do is H. Alright. If I substitute my solutions, alright, gentlemen, when you come in, please do not talk, okay? When you substitute the electric field back into the Maxwell equations, okay, you can see that for these particular solutions, the magnetic field turns out to be H is equal to H naught E minus J K Z E J omega T U Y. Now this E J omega T, a lot of time we do not write because we call it as understood. Alright, understood. So this one a lot of times we do write. Now, you see that they actually have what kind of characteristic? They have the characteristic as they both have the same propagation term. They are propagating in the same directions, z directions. They have the same propagation constant. And what is the polarization? The polarization is in terms of my very famous XYZ coordinate again. If E is in X, Y will be in H, K will be in Z direction. EH, K, X, Y, Z. Alright, so X, Y, Z, EH, K. They are the E, H, and K forms a right-hand rectangular coordinate system. Okay, they form a right-hand coordinate system. Now, this is for simple solutions like this. And what is the relationship between E naught and H naught? The relationship between E naught and H naught is equal to zeta, which is equal to square root of mu epsilon. Alright? And when mu is equal to mu naught, epsilon equal to epsilon naught, then zeta naught is equal to mu naught over epsilon naught is equal to 120 pi, or 377 ohm. Okay? Some people call this 377 ohm, which is approximate, because this is more like 120 pi. Now, why 120 pi? Square root of mu naught epsilon naught, which is equal to the square root of 4 pi times 10 to the power minus 7, 1 over 36 pi times 10 to the power minus 9. Okay, this is mu naught, this is epsilon naught. Okay, which is equal to what? 144 pi squared times 10 to the power of 2 square root. Right? 10 to the power of minus 9, flip out to 10 to the power of 9. So 10 to the power of 2. pi and pi become pi squared, 4 times 36 become like this. So this is equal to 120 pi. Okay, so the mu naught, which is the intrinsic impedance of free space, is equal to 120 pi ohm. Okay, 120 pi ohm. Alright, and this is the relationship of E and H. E naught over H naught, or is over there. Sorry, over there. Okay, so these are all the solutions of the wave equations. Okay, by a simple assumption that I have the electric field in polarized in the X direction, I therefore have a magnetic field polarized in the Y directions, and therefore I have a propagation in the Z directions. Sorry, that should be this way. E this way, H this way, okay, this way. Alright, E cross H equal to K, X, Y, Z, X, Y, Z. Now, but although I start with a simple solutions like this, but why must I have my X coordinate here, Y coordinate there? I can rotate my coordinates. Coordinate system is up to me to define. Alright, so I can, the way I define my coordinate system, I can actually rotate this thing arbitrarily. So no matter how I define my coordinate system and how I define my rotate this so-called right-hand coordinate system, it will remain truthful. Okay, so no matter how it is, E cross H must be in that direction, E cross H must be equal to K. If I like this, E cross H must be equal to K. So it is the general solution. Alright? So in general, alright, I no longer write like this anymore. I write it as detail studies in there, right? Okay. EJ5. Why is a 5 then? Just now no 5, why suddenly a 5 comes in? The 5 comes in order to cater for the most general scenario. Because when you send a signal, sine wave signal, why must a signal like this? At time t equal to 0, why must the signal, the phase of signal equal to 0? Sine wave, right? My sine wave can be anywhere here. Can start here, right? Can start anywhere. So I need to put in an angle 5 to say that, okay, at z equal to 0, it is not necessarily equal to 0. Okay, not the 0 of the sine wave, can be anything, any phase. Alright. Now then, just now I have the E minus j k z, right? Now I replace it as E minus j k. Remember, k is a vector dot r. Alright. K dot r, what does it mean? K is equal to kx ax plus ky ay plus kz az. And r is equal to x ax plus y ay plus z az. Okay. Therefore, k dot r is equal to kxx plus kyy plus kz z. Okay. Now, if we simplify further, we say that the propagation is only in the z direction. So this term go to 0, this term go to 0, and get back to our original, this one. Okay, correct or not? So this is the general term. This is the way it is written in its general terms. Alright? And just now I said the polarization is in the x directions. Now I do not know. I say it is in the E direction. This is a unit vector E. Okay, this is a unit vector E. Alright, so now I have the new sets of solutions. Now similarly, because these two are of the same wave, so you can see that they should have the same propagations. Okay, you see this and this must be the same. Must be the same set. Now, the rest the same. The rest the same. So now your E, this is a unit vector, alright, this is a unit vector, E polarization, unit vector, H polarization vector. E, H, and K will again form a right-hand coordinate system. Same thing. So this one does not change. And all this does not change. This thing here is still the same, whether it is the simple solutions or a general solution. This whole thing still the same. E naught over H naught is still equal to this. Everything else still the same. So from a simple solution, we generalize by two things or three things. One thing is that we introduce a phase here to say that at z equal to 0, it is not necessarily zero phase. Then I introduce as E minus j k dot r to say that the k vector can not necessarily in the z direction, the k vector can be any direction. So k dot r, alright. And finally, I say that the electric field is not necessarily polarized in the x direction, it's polarized in the e direction. Now, you tell me where is E? I say, I don't know. It has depended on questions. Okay, you have to depend on the question. But this is a unit vector. Alright, this is a unit vector and this is a unit vector. But the three unit vector, just like now x, y, z, sorry, x, E, H, K have to be in the x, y, z coordinate system. Same thing, now the E, H, K will also form the same coordinate, right-hand coordinate system. Okay, so it's the same. And the rest, E naught over H naught is the same. Alright? Now, how to find E? This is how you find E. Okay, this is how you find E. If you want to break it into the three components, because if you want to write down E naught E, you can write it as EX, UX or AX plus EY, AY plus EZ, AZ. Alright, but again, all this magnitude we don't know. You have to depend on what the questions give you. Okay, and then the unit vector E is just equal to the vector itself divided by the amplitude. Okay, vector divided by amplitude. Alright. Now, okay, this is what it is. E and H, E cos H must be in the K direction. Okay, K dot R, okay, K dot R is just equal to same thing. If K is only propagating in the KZ direction only, so K dot R is equal to KZZ. Alright, so this is what we have said already. Now, alright. Finally, okay, these two equations comes about, okay, from the Maxwell equations. Now, when the problems, okay, the problem in the tutorial problem, in the quiz, in the exams, a lot of times, okay, is to give you E to find H or give you H to find E. Alright? He either give you E to find H or H to find E. So there are two ways to do it. Okay, one way is from what I told you here, and one way is from memory by applying the equations here. Okay, so two ways. Let me explain them again. All right. If given E to find H or given H to find E, how should you do? First thing, you should recognize that for E and H, they have the same propagation term, same phase, same propagation, same phase and propagation. Of course, different magnitude. Okay, E and H cannot have the same magnitude. Alright, and they cannot have the same vector. Now, but the vector E and H must be EHK. Okay, EHK must form a right-hand coordinate system. So if you are given E, you are given K, you can find H. Or you are given K, you are given H, you can find E. So it's quite easy. And the magnitude E naught and H naught is given by this. E naught over H naught equal to zeta. So you can either do it by understanding what it is, or you do it by using these two equations. Okay, these two equations is derived from the Maxwell equation. H is equal to 1 over zeta K. This is the unit vector of K, K cross E, and E is equal to zeta times H cross K. Okay, so I advise that you keep these two equations also in your help sheets. Okay, in the help sheet, just in case that during quiz or during exam time you panic and cannot remember what the heck, cannot remember what I say. Never mind, apply the equations. Okay, but remember when you apply equation, you must apply the equation correctly. Okay, this is cross product. Okay, this is not dot product. So if you cross product, you must make sure that you get the direction correct. Okay, because the cross product, the directions must still follow EHK. EHK. So K cross E give you H. H cross K give you E. Alright, it must give you, and X cross Y give you Z. Y cross Z give you X. Z cross Y give you minus X. Alright, you must make sure that you get all these cross product correctly. Alright, so are we ready to do some exercise? Because there are some examples. Okay, example now. A uniform plane wave with E equal to EX in the polarized in the X directions, propagate in the plus Z directions. Okay, very simple. E polarized in the X directions, propagate in the Z direction. That means H must be in the Y direction. So really, so simple. Lossless medium epsilon I equal to 4. Epsilon I equal to 4. That means it is not free space. Okay, it is not free space. That means the velocity is c divided by 2, square root of 4 is equal to 2, and the wavelength is equal to the free space wavelength divided by square root of 4, which is also equal to 2. Okay, mu I equal to 1. Assume that Ex is sinusoidal with a frequency of 100 megahertz. 100 megahertz, that means omega. Omega, remember, Ej omega t, that which we understood. Omega is equal to 2 pi f, so it's equal to 2 pi times 10 to the power 2 pi times 100 megahertz. Okay, and then it has a omega. Omega is needed here, alright? If you want to know why omega is needed here, remember, omega is needed here. And it has a positive maximum value of 10 to the power minus 4 volt per meter at t equal to 0 and z equal to 1/8 per meter. Now, t equal to 0 coming in. T equal to 0 coming in. When t equal to 0 coming in, if the questions give you time, okay, then remember this one must have a j omega t, ej omega t written in. Alright, when the equations give you time. Alright, calculate the wavelength lambda and the phase velocity up. Now, phase velocity up is actually this velocity. Okay, phase velocity up. Now, in second year, your velocity of propagations and phase velocity are refer to V. Okay, you will not learn a different velocity because wave propagate with two kind of velocity. One is called phase velocity, one is called group velocity. Okay, one is called phase velocity, one is called group velocity. In second year, you only learn about phase velocity. Okay, you won't learn about group velocity. So any velocity that they refer in the examples or in the exam whatever will be this velocity. Alright? It will be not the, you won't get confused, okay? Calculate the wavelength lambda and the phase velocity UP and find expression for the instantaneous. Hey, have we covered instantaneous already? Never cover. How come suddenly instantaneous come out? Okay, never mind. We take this example as covering it. Okay, first of all, wavelength lambda. Wavelength lambda, if you refer to here, wavelength lambda is here, right? Omega is equal to 2 pi times 100 megahertz. Mu is equal to mu naught mu r. Mu r equal to 1. Epsilon equal to epsilon naught epsilon r. Epsilon r equal to 4 equal to 2 pi over lambda. So the wavelength is here already. Alright? Now this set of equation also worth noting in your in the formula sheets. Alright, the next thing is velocity. Well, velocity is here. V equal to 1 over square root of mu epsilon. Mu is equal to mu naught mu r. Mu r equal to 1. Epsilon equal to epsilon naught epsilon r, which is also there. No issue. Now, instantaneous electric field and magnetic field intensity. Now, you learned that in first year, right? This is what we call the phasor. But you remember phasor form and instantaneous form? This is what we call phasor form. And what is instantaneous form? What is instantaneous form? Anybody remember it? No. You have a E j theta is equal to cosine theta plus j sine theta. Right? You take the real part. That's all. Okay? So the instantaneous form is to take the real part of this. So what are we going to do? We write it as E naught E j phi plus or minus. Now, this one here, E minus j k dot r, since we know that it is propagating in the z directions only, right? It is propagating in the z directions only. Propagating in the plus z directions only. So this one become E minus j k z, right? Okay, is that alright? Is that alright? Okay, huh? So it's minus k z plus omega p. Alright? Alright now? So remember, then you can have real part and imaginary part. Then you take the real part become cosine omega t minus k z plus phi. So this is your instantaneous form. And this is in the ux direction. You know it's ux directions because it is given that it is propagating in x directions. Alright? Okay? So far, this is what you get. This is what you get. Okay, you can find K, you can find the wavelength, you can find the U. Now, they the example here, go and find K. There is no need necessity to find K. You can actually skip K. You can skip K. You can skip K also because V equal to omega K, but you can go directly to 1 over square root of mu epsilon. So depends. This step is optional. Alright? Whether so you put down your formula and this is optional. Now, but why this there is a 10 to the power minus 4 here? Why E not equal to 10 to the power minus 4 there? Why is E not equal to 10 to the power minus 4 there? Where have we gone wrong? We have not gone wrong anywhere because there is another piece of information we have not done yet. Ex has a positive maximum value of 10 to the power minus 4 at t equal to 0 and z equal to 1 over 8. So how? We come back to here. We come back to here. T equal to 0, this term is equal to 1. Right? And hang on. Alright, okay, the reading of question is not very good. Okay, the reading of question is not very good. The reason why, okay, they give you like this, okay, because what they want to do is try to solve for the angle phi. Okay, for the angle phi. Okay, so this one here we have not used it yet. We have not used it yet. But basically, they say that, okay, the equations, the solutions, the person who said this one, say that, okay, I assume that my E naught equal to 10 to the power minus 4 volt per meter first. Okay, I assume that equal to 10 to the power minus 4 first, because after that, alright, after that, I will solve for 5, and if it's not correct, okay, then something will compensate for it. Okay, so this is alright. We just assume for it, assume yet. Alright. Then the next thing is, of course, now you have to make use of these informations already. You have to make use of these informations already because you need to solve for the angle phi. The angle phi is still an unknown. Now you see, because there are two unknowns here, E naught and phi. Okay, E naught and phi. Alright, and this piece of information, okay, one piece of information is not sufficient to solve for two unknowns. One piece of information cannot solve for two unknowns. Therefore, they make an assumption that E naught equal to 10 to the power minus 4. Now then, what they say is that, okay, if I replace this with 10 to the power minus 4, okay, with 10 to the power minus 4, so this is what I have over there. Okay, I sub in my omega, I sub in my k, alright, I sub in my omega, I sub in my k. Now, then, okay, I can assume that, okay, sorry, not assume, I can make use of this particular statement that the electric field has a positive maximum value, okay, at t equal to 0 and z equal to 1,8. Now, how do this value become a positive maximum. This thing become a positive maximum when cosine, the argument of the cosine term equal to 0. The argument of the cosine terms equal to 0. So cosine 0 equal to 1. So that if cosine 0 equal to 1, 1 times 10 to the power minus 4 is equal to 10 to the power minus 4. It is positive. Alright, so that is how they find the angle phi equal to pi over 6. Alright, now as I said, this question is not very well set because if we don't make this assumption, then I will end it up with like this. 2 steps. Okay. I will have ended up like this 2 steps. E naught cosine omega must be equal to 10 to the power minus 4. Okay, I'll have to do it this way. This is my requirement. E naught cosine this one equal to 10 to the power minus 4. It must be positive and it must be maximum. Alright. Now, what is the maximum value for cosine? The maximum value for cosine is 1. Correct or not? The maximum value for cosine is 1. Therefore, E naught must be equal to 10 to the power minus 4. Because the maximum value of cosine is 1, this one must be 10 to the power minus 4. Okay, so that this thing maximum, this thing will get 10 to the power minus 4. Okay, so the reasoning should be like this, and not basically just put E naught equal to 10 to the power minus 4 right in front. Alright, should start from there, saying that, well, if this thing, the maximum value of this thing is 10 to the power minus 4, the maximum is 10 to the power minus 4, it means that the maximum value of cosine is equal to 1, so that E naught is 10 to the power minus 4. Alright, the reasoning should be like this and not basically just put it right in front. Alright, so once you do that and then you solve, now phi equal to pi by 6, so this is my electric field. Okay, this is my instantaneous electric field. Now, what happens to my magnetic field? Now, the magnetic field you can obtain using this formula here. You can obtain using this formula here. Alright, or you can obtain doing by reasoning. H equal to H naught must have this form, must have the same form, everything must have the same. If everything must be the same, okay, if this is my E, if this is my E, and everything must be the same, what does it mean? All the propagation must be the same. Where is my head? Can I write it down without looking at the solutions? Yes, I can. I can have a H naught, which I have to find after that. This thing exactly the same, so this thing exactly the same. This is X, propagation is Z, so this is Y straight away. Then what is this H naught? Remember, E naught H naught equal to zeta. So my H naught equal to E naught over zeta. This is equal to E naught over zeta. And what is my zeta? Zeta is equal to mu over epsilon. In this case here, epsilon r equal to 4. So this is equal to 60 pi. 60 pi. Why 60 pi? Because mu is equal to mu naught divided by square root of epsilon r is equal to mu naught divided by square root of 4, which is 120 pi divided by 2. So straight away you get the answer of 60 pi is here, so you get the answer right here. Okay, you get the answer right here. So in fact, you don't have to do all the equation, try to find the cross, because E cross H is equal to K. Alright, any questions? what else did they ask? Okay, determine the positions where Ex is a positive maximum at the time t, at the time instant t equal to 10 to the power minus 8. The position where Ex is a positive maximum when time t equal to 10 to the power minus 8. Phi we already found out already is pi by 6. T equal to 10 to the power minus 8, and it has to be positive maximum. Once again, the cosine must be equal to 1. Alright? So same thing. Okay, so same thing. The cosine must be equal to 1. And cosine equal to 1, why suddenly become 8? Minus 2n pi. Equal to minus 2n pi. Now, cosine equal to 1 when the argument equal to 0, 2 pi, not pi, because pi, cosine pi is equal to minus 1, so it's a negative maximum, not positive maximum. So 0, 2 pi, 4 pi, 6 pi, so 2n pi. But why is there minus sign here? Why is a minus sign here? I'm quite sure that a lot of students will get this part wrong. Okay, why there's a minus sign there? Sorry? No, because basically you see from here. Okay, you see from here. If this is positive, okay, Z is here, they want to find the position Z. Z, you move here, become positive, right? This one, you move over here, become, if this is positive, you move over, become negative. Now, this is a small value, this is a small value, so it become negative equal to positive, that means your Z will become negative value. So if you put 2n pi there, all your solutions, there's nothing wrong. There's nothing wrong, okay? Because this is your time t equal to 0. Time t equal to 0. Okay, now when the wave propagates is like this, time t equal to 0. So if you put positive 2n pi there, your solutions are here at the negative pi. Nothing wrong. Because they never say, the questions never say, so if I mark this question, I'll mark it correct. Because, you know, the positions where Ex is equal to positive. So it is behind, the Z all behind. Okay, all the Z, sorry, this is Z equal to 0. Okay, it is all behind. Okay, but if you put 2n pi there, the solutions are in front. Because if it's minus 2n pi here, we can see that when you move over, become positive. So positive equal to positive, the Z become positive. Alright. So this is actually just a small tricks down here, so that your solution is positive Z and not negative Z. You know, but there's nothing wrong even if you get negative Z. Alright, any other questions? You need 5 minutes to absorb.
Yes.
Pretty loud. Okay, any questions? Any questions? Okay, while you take a rest, okay, I just repeat, okay, repeat again and again and again, okay. EHK forms a right-hand coordinate system. E over H is equal to zeta. Alright? So these are the two most important things that you need to know in this chapter. E cross H, direction K. The ratio between the magnitude EH equal to zeta. The rest are all equations. The rest are all equations. All these equations here, okay, you should have it or have them into your help sheets. Alright? And okay, meanwhile, while we are taking a break, okay, let me show this again. this is a reminder from university that you have to do your data protections module by 10th of December. Otherwise, I don't know what they are going to do with you. Okay, it's a mandatory. Alright. And for those who missed the quiz with valid reason on Friday, please come to EE2011, okay, to have a retest. Alright, we have a retest. And by the way, who is Ye Jiayi? Alright, you submitted your help sheets together with your quiz. Yeah, all the formula and 2 marks for each formula. Okay, yeah, it's okay. It's okay. You send me an email, right? Send me an email. So you just think of I won't be there by You see, it's a functional precision. The field strength is a functional No, I become Z because when it is only propagating in the Z direction, it's only field strength. Okay, if it's propagating in the Z direction, so if this one becomes it is a function of Z. In XY direction, plane wave is a function Alright, is everybody back already? Anybody? Somebody? Okay. 1 more minute and then we'll start. Alright. It's only a short How bad? I don't know yet. Not finished marking. Not finished marking. By the way, usually what we will do is that we will set aside a time of one afternoon for 2 hours or so. Okay, for those of you, after we have graded the paper, we will actually have the marks on the grade books. Okay, and those of you who wants to look at your scripts, okay, we will not give you back the script, but we will set aside a time. Those of you who want to take a look at scripts, okay, to say that, hey, I deserve more marks, then you can come during that 2 hours or 3 hours.
So you pay $10
No need to pay. No need to pay, okay? And any grade also you can come. Even if you get 99 marks, you can come and say, hey, I deserve 100. So that's okay.
I don't think there's anybody at 99 marks.
Hey, don't be surprised, no?
How
Don't be surprised, no? I have marked some scripts. There are a few of the 3 questions that are already marked get full marks. 75 out of 75. Still one question not graded yet. So we don't know.
Very my legs. Very my legs. Nice. Like that already. Now the legs is like a few people. Our legs spread already guys. Very dark sex. Easy C.
Alright, ladies and gentlemen, let's come back. Okay, for this last question. Alright, gentlemen, ladies. Okay, this number 5.305 times 10 to the power minus 7 is actually 10 to the power minus 4 divided by 65. Alright, remember this H naught is equal to E naught divided by zeta. Alright, H naught equal to E naught divided by theta, so 10 to the power minus 4 divided by 65 give you this 5.3 times 10 to the power minus 7. Now let's look at the next example. Now this example is simple because E has only one component. E polarized in EX component. Okay, only. Now the next example is give you H. But H has 2 components. H has 2 components. One component polarized in the X direction, one component polarized in the Z direction, and this is like this. What does this mean? What does this mean? Okay, so now I have H, X, Z, T, equal to minus 1 over 15 pi X plus 1 over 20 pi Z cosine omega t minus 6x minus 8z. What does it mean? What does it? Okay, it means that it has two polarization component and it also has two propagation components. Because our general form is E minus jk dot r, which is equal to E minus j kxx plus kyy plus kzz. Remember? Alright. So what does this mean is that now k, I have my kxx, I have my kxx, I have my kzz, because I have x here, I have z here. So I do not have kyy. Alright? I do not have kyy. Now, to solve this problem, okay, what is the problem that you want to solve? Define, calculate k, calculate lambda, calculate omega, and find an expression for instantaneous electric field. Now, to this kind of questions, what we usually do is write them in phasor form first. Okay, phasor form, what do I have in phasor form? Phasor form, this part is still the same. Remember, the magnitude part is the same, but we change the cosine part into the exponential. So this one becomes E j omega t E minus j 6x plus 8z. Right? Okay. So I do this, I transfer it into phasor form. Alright. So now, what is my k? I can say that it is equal to 6x plus 8z. 6x plus 8z. Right? Because k dot r is equal to kxx plus kyy plus kzz. This is 0. This is equal to 6x plus 8z. So kx is equal to 6, kzz. Alright. So what is the magnitude k? The magnitude of k is equal to square root of 6 squared plus 8 squared. Right? Which is equal to 36 plus 64, which is equal to 10. Okay, it is equal to 10. What other things that do we need? Okay, I have found k already. No problem. I have already found k. Okay. Lambda, well, lambda no problem. Lambda is here. K equal to 2 pi over lambda. Okay, k equal to 2 pi over lambda, so lambda is equal to 2 pi divided by 10. No sweat. Now, then, what is omega? What is omega? How to find omega? No sweat, right? Because you just read the question carefully. In air, mu equal to mu naught, epsilon equal to epsilon naught. So I have k equal to omega mu naught epsilon naught. K naught is equal to 10 equal to omega square root of mu naught epsilon naught. So I can find omega. No sweat already. So these three are all gone already. These three are done. Okay, these three are done. Now H naught, well, is it really necessary to find H naught? I don't think this is really necessary. I don't think it's really necessary. Alright, I don't really think this is necessary, but if you remember these equations here, remember E is equal to zeta H cross K. Right? E equal to zeta H cross K. So I think we are able to find E. What is zeta? Zeta is zeta equal to zeta naught, which is free space, right? Zeta equal to zeta naught equal to free space. So I rub it off, I just write it right here again. E is equal to zeta H cross K. So it is equal to 120 pi. Now what is H? H is right here, right? H is right here. So I write down minus 150 pi x plus 120 pi z cross K. Now this K is equal to 6x plus 8z, right? Okay, so what is the K? What is the K? Unit vector K? Unit vector K is the vector K divided by the magnitude, right? And so this is equal to 0, 6x plus 8z divided by 10, which is equal to 0.6x plus 0.8z. Am I correct? Everybody can get? To apply the equation E equal to zeta H cross K. Zeta is 120 pi. H is down here. I just copy it down. I just copy this one down. No, sorry, I didn't copy completely. So you have E j omega t E minus j 6x plus 8z, okay? And then cross. And then cross what? Cross the unit vector of K. Now, unit vector of K, the vector of K is equal to 6ax plus 8az. So, unit vector of K is equal to the vector of K divided by the amplitude of K. Amplitude of K we already found is equal to 10. So, 6 divided by 10 is 0.6, 8 divided by 10 is 0.8. So, this is cross 0.6x plus 0.8z. Right? Okay? Yep. Everybody okay? Now then, the next step is just be careful. I just multiplied this 120 pi in first. 120 pi and pi cancel. Pi and pi cancel. Pi and pi cancel. 120 divided by 20 is 6, right? 120 divided by 20 is 6. 120 divided by 15 is what? 8. Minus 8, huh? So it's minus 8. Okay. So there you go. Now, cross. I write down the rest unrelated part first. Write down the unrelated part first. Now I want to cross these two vectors. cross these two vectors. AX cross AX, 0. Okay, the cross product of the same vector equal to 0. AX cross AZ, minus AY. Alright, now AX cross AZ equal to minus AY. So minus minus become plus, plus 8 times 0.8, 0.64. Right? Then Z cross X. Z cross X is Y. Okay. Z cross X is Y. 6 times 0.6 is equal to 0.36 Y. Z cross Z equal to 0. So that gives me 0.6 Y is equal to 1. 1. Y EJ omega T EJ minus J 6x plus 8z. So this is my phasor form for E. Now, if this is my phasor form for E, as you can see that the solution is already there already. Where is the bracket 1 to 10? Where is the 10 come from?
I think that one, the 0.8 times 8 is 6.4.
Sorry?
One when you cross.
0.8 times 8. 0.8 times 8.
Oh,
Yeah, you see, 8 times 0.8 is not 0.64, it's 6.4. Alamak. So this is 6.4. And 6 times 0.8, 6 times 0.6 is 3.6. Okay. Okay, so it's 10. Yeah, okay. Okay, so now you get this. Okay, you get this. And then the instantaneous form is just basically just that. So it's not difficult. Okay, all you have to do is just follow the steps one by one. Follow the steps one by one. Any questions? Now one more time. All right. Now this one looks very scary. Looks very scary. Alright, look very scary. But not to worry, you just do it step by step. You look at this one here, what does it mean? Okay, you just convert in the phasor form, it will be very clear. Okay, to convert this instantaneous form to phasor form, the magnitude part is the same. Now the cosine part is the phase, okay, the phase part, okay, the phase part. So when you convert the cosine, you write it down to your exponential. We just copy everything down. Now when I say copy everything down, this thing must be in a standard form like this, okay, because I think it's about time for me to rub this off already. Because the phasor form is real EJ theta is equal to cosine theta. This is how you convert your phasor form. Okay, this is a standard phasor form conversion. So you write down into this. And once you got this, okay, you are asked to find K. You are asked to find lambda. You are asked to find omega. Now, to find K is very simple because the vector K is already given here. Okay, this is Kxx plus Kzz. Alright, so the vector K is just equal to 6 ax plus 8az. There's no ay term because there's no y. Xz, there's no y. Okay, if that is the case, what is the magnitude of the vector k? Magnitude of the vector k is just equal to square root of 6 squared plus 8 squared. Alright? And the unit vector is just equal to the vector divided by the magnitude itself, so everything is fine. So the magnitude of k is 10. It's already given here. And k is equal to 2 pi over lambda. So lambda equal to 2 pi over k is equal to 2 pi over 10. That's also k. Then what is omega? K is equal to omega times square root of mu epsilon. Okay, since this is a, mu equal to mu naught, epsilon equal to epsilon naught. So 10 is equal to 3 omega times square root of mu naught, epsilon naught. Omega also can be found. Then the next thing is to find E. Now to find E, we have these equations because this is more difficult to do all the equations. So I go back to the equations to be much easier. So I write down my zeta is perhaps value high because it's a free space. Alright, H, write down the phasor form cross the unit vector of K. Unit vector of K. And when you do all these calculations, do it carefully. Okay, just now I made mistakes already. Alright, and make sure that you multiply, you cross it, you get the direction correct, you get the magnitude correct, so you get the final answer. Once you get the final answer, okay, you convert it back. Okay, there's no need to write down all these H. There's no need to do this one, find H naught. There's no need to find H naught. There's no need to do all those things. Okay, which is actually no need to. But at this point here, I want to give you a reminder. This is the standard form. Now, what happened if my questions, just now the question is like this. Cosine 6x plus 8z minus omega. How? Can I say that now the phasor form is E minus j omega t E j 6x plus 8z? Just now is cosine omega t minus 6x plus 8z. I get this. But now this doesn't mean I get this. The answer is no, alright? The answer is no. 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 Although this is a correct solution, remember these correct solutions, we say that this is a physicist solution. We do E j plus j omega t, they do E minus j omega t, which is not the correct solution. So what do we do for that one? Well, this one, I just turn it to omega t minus 6x plus 8z. Minus 8z, can or not? Can, right? Because cosine minus theta equal to cosine theta. So you put it back. Okay, remember when you convert, it must be in this form. Now, what happens if, let's say, now I have this one? Sine. What happens if I sine now? I cannot write. What should I do? Remember, my standard form must be cosine omega t minus kz, something like this. It must be that like that. The k here must be a negative sign. The omega here must be a positive sign. We must do that. And this one must be a cosine. So these three conditions must be met. Okay, sorry. This one not necessarily minus sign. What happens if this one is a plus sign? let's say first, what happens, this is a plus sign. If this is a plus sign, let's say it is cosine omega t plus 8x. Let's say what does it mean? It is, the phasor form is e j omega t e plus j 8x. So it means that the wave is propagating in the minus x directions. Okay, it is this is minus 8, this is minus 8, it's propagating in the positive x direction. If this is plus, it is propagating in the minus x directions, because k is minus now. Okay, k is minus 8. Alright, now what happens if I got this one? Okay, so the thing is that omega must be positive and it must be a cosine. Okay, these are the two determined characteristics. So what happens if I got this? Sine 6x plus 8z minus omega t. What should I do? What should I do? What should I do? Very simple. Let's say you have sine pi by 2 minus theta is equal to sine theta. Cosine theta, right? So no, I want to do cosine. Yeah, this is correct. Am I correct? Correct, huh? Correct, huh? So how should I convert it into cosine theta? Or if you have problem, okay, if you have problem, alright, if you have problem with orders, now, this can be equal to minus sine omega t minus 6x plus minus 6x minus 8z. Okay? Because cosine minus theta equal to cosine theta, but sine minus theta equal to minus sine theta. Am I correct? Okay. So now, how to change this to cosine? How to change this to cosine? Because pi plus pi over 2 plus pi over 2 minus pi over 2. Then how to add? How to add plus pi over 2? Okay. Alright, I'll set this one for the next class test. Alright. So I have 2 class tests already just now. Okay, I will give you hints already. Alright. Just now I will given hints for you another class test already. Okay. Because I need to finish this one, so I will revisit this one when we come back. Now the last thing that we want to finish off with this chapter is power flow. Okay, power flow and pointing vector. Now when you propagate wave, okay, not only the wave is important, okay, not only the wave is important, but also power flows is important. Okay, what is the power in the sense of your voltage and current? Power is equal to V times I, right? And if it's complex, it's V times I conjugate. Now, pointing vector, on the other hand, is our power density. Power density, why? Because E is equal to V over D. H is also equal to I ampere over meter. This is voltage per meter, this is ampere per meter. So it ends up watts per meter squared. Okay, so power meter is actually the E times H. Okay, and the average pointing vector, the average is within one period, this is integrating within one period, it becomes half of real E cross H, which is also the same as equal to P is equal to half of V I. Now, where this half comes from? I conjugate. Where this half comes from? Where this half comes from? Same thing. This half comes when V is a peak value. Okay. When if it's RMS value, this half is not there, so it's peak value. Now this electric field, of course, we are denoting peak value, so E and H, so the half is there. Alright. And where is the power flow? The pointing vector is always in the directions of K. Pointing vector is in the direction of K, because if the wave propagates this way, the power flow is of course this way. It cannot have the wave propagate this way and the power flow the other way around. I mean, this is ridiculous, right? So this is intuitively correct. Alright, so this is, if we have a E, we have a H, okay, so we have the pointing vector for in terms of E naught or in terms of H naught. Now, these two equations again is very similar because if you recall, okay, P is equal to half of V squared R, V squared over R, which is equal to half of I squared R. Remember, this is your power, this is your power density. So it's half of E squared over zeta, which is the characteristic intrinsic impedance, or half of H squared times intrinsic impedance. So it is similar, okay, it is similarity. And once again, remember these two equations that you need to use very, very often. Okay, just one final example. We have seen this example here. Compute the average power density of a uniform sinusoidal plane wave. Okay, we have the following expressions. Alright. Now we have to find the power density. We have already found the H field and we have already found the E field from the second example. Alright, so from there we say that half of real E cross H conjugate. Okay, so we take E here, H conjugate. Now, you understand what is the conjugation, right? Conjugations means that this part here, minus become plus. Okay, this minus become plus. Alright? So when you do the conjugations, you can see that, so on the face here become E minus j theta times E j theta becomes 1. So when you do the cross product, the power becomes real. Alright? Okay, this guy is crying because he's so much max, and he also don't know whether he can pass or not.
So I think
Alright, that is the end for the plane wave propagation in lossless media. Now in lossy media, the concept is not much different. The only issue is that, okay, remember just now we have epsilon, epsilon, epsilon equal to epsilon, epsilon r. Now for lossy material, epsilon must be modified in order to accommodate the conductivity of the material. Because remember, a lossy material, in a lossless material, everything is displacement current density. There is no conduction current density. But in a lossy material, there will be displacement current, there will be conduction current. So your epsilon must be taken into account the conductivity of the material, and everything else is the same. Okay, all the equations will be the same. This equation will be the same, and all the k equal to omega mu epsilon will be the same. Everything is the same, except that now your epsilon is replaced by a so-called epsilon c. Epsilon c taking into account of the lossy material. All right, any other questions? Suggested reading. Okay, if you go for textbooks, these are suggested reading. All right, any questions? Okay, if not, our final this one. Okay, like that, it's simple. And while you are doing, I have an announcement. I think this every 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 38, 39. Hey, come on! Every time I receive almost have 40 over submissions, but don't seem that I have 40 over students here. Don't submit on the behalf of your friends. By the way, while you're working on the solutions, I have an announcement to make. This Friday, I can't make it to the lectures. Okay, you guys, don't be wild. You might need that. Okay, I can't make it to the lectures, so this Friday's lecture has to be cancelled. We will, when the time comes nearer to exams by November, then we will look at the situation to see whether we need to have a makeup or not. Alright, then we will look for a makeup at that time. Because now it's still too early. Okay, the reason why it's too early because the other lecturers are actually at a slower pace. Some of them did not do makeup for the Hari Raya Haji. So they are actually one class later than us. So not so bad. So this Friday there will be no class. Okay, there will be no class, and then I will see you on Tuesday. All right, I will see you next Tuesday.
Alamak, I must come school. We don't need come school.
Then your problem lah.
You come for, I
错错，这套的话你袂使哦。
You are a good student, no problem. Actually, it's easier than the just now the example 2, right? The example 2, they have two component, two polarization component and two propagation component. This one has only two polarization component, one propagation component. This one polarization component, two propagation component. Remember your cross. Okay, your cross just now when I do example 2. When I do cross, okay, two component, cross. So it's component by component. Okay, you can do component by component.
How do I know about the
365 divided by the So 365 divided by
你没有 P 吗？
P 的100，然后这里是100克，然后这里100克。
对呀，1 1 2 2啦。 一日换3。
Then it says